All right, we're good. I can hear things. Awesome. So we're going to get started with passwords. Passwords. All right. First things first, let's announce some stuff. Happy November. So the challenges that were all the special stuff of last month, they're not done. You can still, okay, they're done, but they're still going to remain up. You can still do the challenges if you want to. You're not going to get the cool coin. But if you did participate in the challenges and want your coin, go claim it from Lauren. Yeah, whoops. But that's it for challenges. What else? Tutoring. So we're going to try out tutoring for computer science, cyber stuff for now, from now on. So after ACE meetings on Mondays, after this meeting, every Monday, I'll hang out. You can come to me for help with your 130, 120, maybe not 120, but 130, 220 series, computer science, cyber. Whoever else wants to stay, they can also help. Also on Wednesdays, 5-ish to 8-ish. We'll loose time, but if you need help with class stuff, cyber CS, Monday and Wednesdays. Cool. Okay. What else? Am I forgetting anything else, Seth? No? All right. Thanks for that. What would I do without you? Okay. So passwords. Yeah, passwords. So yeah, that's me. I'm John. Hi. So first things first again, please don't do anything dumb, but we're going to show you how to do dumb things. So don't get caught if you do. If you do crack somebody's password, it's really their fault, but don't do it because you'll get in trouble, and that's your fault. So if you do get caught, we're going to make fun of you, and that's not fun for you. It's fun for us, but not for you. All right. Hey, what's a password? Educate the classroom. What is a password? You asked, now answer. I asked, now you answer. All right. Well, does anybody else want to answer the question? What's a password? It's a password, word of passage. You see word roots. Yeah. So basically, yeah, a password is something you use to gain access to something. Password, passphrase, key phrase, same jazz. How are they used? They're used like you would normally use a secret phrase. I don't know, man. I just pasted this off of a previous presentation. When are they used? Well, if you want to access something that you want secure or you don't want other people to access, you want something, for your eyes only, you would use a password, et cetera, et cetera. So complexity, aspects of passwords. Don't worry, guys. Size isn't everything. Sometimes it's pretty good to have things long, but it's not everything. Complexity is pretty important. All right. So if you can see that, it's pretty small, but that's for an Excel spreadsheet from the SANS Institute. Basically, I'll try to explain it. So if you're using a small combination of characters, basically only A to Z, lowercase, or maybe A to Z in numbers, you're still on the very low end of complexity size. So you're ranging 26, 36, 52 at the max, 62 at the max. That's not a lot. Even if you have, so let's say you have your password as a letter A 14 times in a row. That is less complexity than every ASCII character or a combination containing something in the list of every ASCII character of size, I think 8. So 14 is longer than 8, but doesn't mean it's better, okay? That was kind of what I'm getting at. So basically, if you take every ASCII character and printable ASCII character and put it into a password combination, you have up to 95 different choices. And for complexity, it's 95 raised to n length the password. So as you go higher, it gets, it's way up, it's exponential increase, right? Right. Types of passwords. There's 3 that I could really think of. There's your standard, there's, your username, your email address, and your password. The main thing you need to know about that is don't use the same one over and over again, because I know we all do it, but the main, like the secret, I guess, or the fad nowadays is using a password manager. Basically, you have one master key that unlocks the passwords for a bunch of different sites. I know Google Chrome has one, I think, or like password generator. That's what I'm trying to get at. Basically, you generate a random, stupid, long password that's really crazy complex. You're never going to remember it, but Google does it for you, and you can unlock everything with that one master key. That's kind of what the fad is now. There is also the cryptocurrency key phrase. These are 12 to 18 to 24 word key phrases. So like I said in the previous slide, you're only limited to 95, unless you're like using a Spanish keyboard, maybe a little bit more, 95 combinations. But if you're using key phrase, it's kind of like a password of miniature passwords. So I'll pull this up. There's a file that has 2,048 lines with it. Let me zoom in. Come on. I am on presentation. Thank you. I'm getting there. Come on. Come on. I'm getting there. X out. There. Okay. So yeah, it's 2,048 lines with a bunch of different words. Now, we were limited to 95, right? So now you have 2,048. So let's pull out a calculator. Let's say you make a 10-character password out of random ASCII, 95 raised to the what, 10? That's pretty big, right? You can't really see that, can you? Come on now. There you go. It's a pretty big number. Now we have 2,048 different combination words to pick from. So, and let's say it's 12-word key phrase, 2048 raised to the 12. That's a little bit bigger, right? And in some cases, like the new Ethereum wallets, they have 24-word key phrases. So that's 2048 raised to the 24, which is just a little bit bigger. So to crack those is pretty much right out, unless we hit quantum tomorrow. I don't think we're gonna crack those anytime soon. But yep, that's why cryptocurrencies are pretty cool. Back to where we were. Yep. Okay, and then the last one, which is actually really, really cool. It's called Cryptographic Key Authentication. It's similar to, it uses blockchain technology, internet computer, if you've heard of that. They use cryptographic key authentication. Basically, it's different, what's it called? Next slide. Well, I didn't name them, but basically, 3 of these are used in there, and I'll show you that. I'll show you that as well. All right. Let's go with OpenChat. This is basically a blockchain WhatsApp. And look at that URL, if you can see it. That's one crazy looking URL. Welcome to the Web 3.0. It's blockchain-based internet. Pretty cool, right? So to sign in, it's gonna be 3 things. 2 of them you'll see off the bat. So 1, identity anchor. That's mine. That's like your username, right? It's one aspect of something that you know, right? Authenticate. And it's gonna query the hardware for authentication. Number 2, something else that I know, right? So you have to, 2 things, know my sign-on ID and also be on this machine, this actual machine. So we're gonna proceed, it's gonna log me in, and that's gonna take a hot second. And I'm in. But this uses what's called internet computer. I will pull that up, internet identity, actually. So I'll pull this up. It's gonna make me authenticate again. Log in. So I only have one device. It's a whitelist. It's a device whitelist. Essentially, you can only get in you can only log in via internet identity if you are 1, know my username, 2, know my login on my laptop, and 3, are on this laptop. I can also add a new device if I wanted to the whitelist, but I can't do that because I need a 4th thing, a Windows security key, one of those plug-in USB keys. So this is like really futuristic kind of like technology, So like The only possible way you could log in is to be me, really. You have to know a lot about me, know 4 different things about me, and also have something in order to add your own laptop device. And it's going to scream at me. There is a way to recover. The recovery phrase is like the 12-word key phrase. Kind of hard to remember. I did put it up in this PowerPoint slide, didn't I? Yeah. Something long like that. Embark, alcohol, dinosaur. Yeah. Huge, long. You're not going to remember it. Cracking it as a right, pretty much right out. Yeah. So what I was trying to segue into was forms of multi-factor authentication. There's 5, and I think these are in order of how much they're used. So something that you know a password, right? You know your password. Something you know, that's 1. Something you have, 2-factor, like your phone, you log in with the Google Authenticator app. Basically, same thing. Something that you have, something that you are. These are fingerprint scans on your phone, retina, cornea scans, the handprint on the spy movies, that kind of stuff. Excuse me. Somewhere you are. So these can be device whitelists, but that's mostly usually something you have. But let's say the virtual machines in tech, you can only access them if you're on the tech subnet, right? So if I were home, I can't whip up a tech virtual machine unless I'm using the tech VPN, because it whitelists somewhere that you are. But you can kind of bypass that with something you have, right? So in that way, some dude in Russia can't spin up a tech VM and hack us or something like that. And last one is something you do. This one's really uncommon, but I think it was Despicable Me, the second movie, where the guy does the dance on the floor and it like highlights, does his dance to get into the secret base, that kind of stuff. Something you do, right? Really pretty uncommon, but it is used. I can't think of anything off the top of my head. Also, with something that you have, if you work for the government, you're going to be given, I forget what they're called. They're called like CSA IDs, but you use those to like your dorm. You open your dorm with the key card. Same thing, but use it to log in, open doors, get pretty much anywhere. Your identity is that key card that you have. Yep. Okay. Password practices. So passwords, when they are stored server side, they are stored via hash. They're supposed to be, stored via hash. Neopets, remember them? They store your passwords in plain text, and they got smoked. So my password that was on Neopets is now out and about, but it was a terrible password. It was baseball 1999. It was not a good password anyways. So they're supposed to be hashed for stored hashing. Hashing is a one-way byte conversion. So if I input something like ACE, the output is something like that, complete gobbledygook. So if you hack a database and get all hashes, you can't go backwards. Really, you can't go directly backwards, but there are ways to bypass that. We'll show you in a minute.
How long are hashes?
Hashes are as long as you make them, but depending on the hash algorithm, which are shown, MD5, SHA, CRC, Whirlpool, those dictate how long the hash is going to be. Those ones on the screen right there are MD5 hashes. MD5 and SHA-1. MD5 stands for Message Digest, SHA, Secure Hash Algorithm. Those two are have known collisions, meaning that there are documented cases where 2 different inputs result in the same hash. The purpose of hashing is to produce something that is unique and something that can't. Purpose of hashing is to produce something that is 1, unique, and 2, unreversible. So with, I think, SHA-256, it's 2 to the 256 different combinations, right? And the length is 32, because it's 8 bits in a byte. Yeah, so 512 is 64. You get what I'm talking about? Cool. So the same thing with 512, 2 to the 512. Very big number of combinations. Theoretically, yes, there are collisions, but the odds of hitting one are pretty slim. So that's why hashes are used for file integrity, file transfer, checksum, stuff like that. We can talk about hashes for a whole meeting, but just kind of a brief touch on those. Salting. So salting is what is used to add extra complexity to a password. So let's say the password is ACE, and we can slap on 16 random characters to append to that password and then hash that. That way, because there's lists of a bajillion terrible passwords, I don't know if there's going to be a list that contains this in there. You know, oops, I mean, that was a mistake. But I don't think there'd be a list that has that exact hash or the hash of that exact password. So hashing is what's used to put a little bit more integrity into people who put bad passwords. It's common practice nowadays, and salting is unique per each password entry. So it will be stored on the database. So let's say if I capture 1,000 password hashes, I will have 1,000 different salts that I have to also use with my testing, and that'll take a lot more time and that'll suck, right? There's also what's called peppering. Peppering can be used alongside salting. It's slightly different because peppering encrypts the hash, does not hash alongside it, which is what salting does. The difference between encryption and hashing is that encryption goes both ways. Hashing is one way. So let's say it's like a master key. No, I mentioned that earlier. A master key will unencrypt the plain text passwords, unencrypted passwords back into plain text, so you can see them, what they are. You can use them to log in. So yeah, hashes password as usual, and then encrypts it, sticks it into the database. The pepper would not be stored in the database. That would be redundant. That wouldn't help. And there's also, like, Microsoft, I'm pretty sure, practices like pepper rotations, like every couple of months, I think. Password attacks. One is brute forcing. So like I said, you can't go backwards from a hash. But let's say if I hashed every combination of characters between 1 and 14 length, yeah, I'd probably get a lot of passwords, right? Because I don't think a lot of us have passwords that are more than 14 characters. I don't think so. It'd be pretty cool if you did. But I think the standard is 15, right? 14, 15? Yeah, it's long. But in a shell nut, basically you're guessing a bunch of common, in some cases commonly used passwords, a bunch of different combinations, trying to see if this hash matches with this hash. If not, go to the next one, try it again. Will be tools used for that are John the Ripper, Hashcat, Medusa. I think John uses processor, Hashcat uses graphics cards, I think. Okay, well, I'm kind of right. There's different kinds of brute force attacks. There's a dictionary attack, basically word lists, easy passwords like password 123, baseball, let me in, easy, simple passwords. Just use those predefined words and hash against them. See if somebody's dumb using a terrible password and see if they match up, and you can use it to log in as them. There's also password spraying, meaning you'll be using the same guess among different accounts in an attempt to bypass, like, oh, you messed up 5 times in a row, we're going to lock your account. To bypass that, you can use what's called password spraying. I think there was a spray attack against Microsoft, I think like 3 days ago, I think. I meant to retweet on the Ace Twitter account, but anyways. Other one is pass the hash. So the server is expecting a hash value, and then they compare. Let's see, if I log in, my password, I tack it in, it gets hashed. Server goes, hey, this is what you're looking for. These match up. You're in. So if the website is coded poorly, you could simply pass the hash. You have that. Let's say you have the hash. You don't know what the password is. You could just pass it into the server, and they go, hey, this is what I'm looking for, and I'll let you in. Those are pretty uncommon because people pay attention to that kind of stuff. But some cases they won't. They'll go, hey, this is a hash. Is this the right hash? Yeah, let them in. So there's credential stuffing. Basically, damn it, what's that one called? I think it's where you use all their personal information as much as possible to try to force a password. Like, I'll put my name you know, first name, last name as the password, you know, my birthday, you know, that's credential stuffing, using what you know about them to apply password cracking. Man in the middle, we did this in the second meeting of the year where we made the fake website. We were the man in the middle, right? As they were trying to connect to Moodle, sorry, to Moodle, input their password. We were in the middle, we caught it, and then we screwed them over, right? Phishing, same kind of jazz. Like, oh, we'll log in for you, you know, stuff like that. More geared towards people who are dumb. Cool. Let's do some stuff. Cat, cool, and crunch. So we can use Hashcat. Ooh. So Hashcat is a. As I get my VM pulled up, Hashcat is a tool that brute forces passwords. Basically, it's a tool used to crank out as many hashes as possible. Actually, while I'm thinking about it, get this out of the way, go away. Let's go, what's the Bitcoin hash rate? Let's see how many hashes you can churn out. So let's say I can churn out, I don't know, my laptop, I could probably churn out a couple thousand hashes a second, right? Well, with Bitcoin and the current hash rate, which is 159 million terahashes. So hash, millihash, wait, kilohash, millihash. I'm thinking about it. Give me a minute. Hash, kilohash, millihash. Is it megahash? Megahash, gigahash, terahash. So that's 18 zeros. Oh yeah, it's exahash. Well, 100. That's a lot. It's a big number of 256 hashes just getting churned out and thrown away. Because I think those ant miners get like 100 terahashes a second or something. Those are like ridiculous. But if you got one of those, you can churn out a lot of hashes. You know, you can start cranking stuff. I think there's like a password complexity. If I can Google it, password. I don't know. I think it's complexity, or how good is my password? I think it's what it's called. Let me check this one out. I put this over here. I think this is it. Maybe. Is it? Oh yeah. So, you know, let me key in the password as I put in, you know, underscores and numbers. That's what, 8 in 19 minutes. It's pretty bad. This is old. This was used like 10 years ago. But let's say if it takes a computer 19 minutes to crack an 8-character password, it'll take an actual computer that isn't this stupid website a couple seconds, because hashes are just, you know, they get crunched easily nowadays because graphics cards, man, those things can crunch. So Hashcat utilizes that. You know, segue, Hashcat is what it utilizes your graphics card as much as it can to crack and crunch password hashes to see if hashes line up. All right. Doing this on the fly. Yep. Get it away. So if you want to make a fresh, clean hash, basically, echo, you're going to get rid of the new line character because that'll ruin your hash. But hi, pipe that into, y'all can't see that. Let's see, easy. As I make this bigger. And to, for example, MD5 sum, here's a hash. Ta-da. And if I change, I don't know, one letter, hash is completely different. Yep, let's try a different hash. Let's do SHA-1. A little bit longer, a little bit more complex. A little bit bigger, and then 512 is double that, even bigger. So let us pipe that into, they strip off the hyphen because reasons. Passes.text, right? Ho, that's into a file. Do I, hang on, before I do that, do I have anything else in there? Oh, I did do that, damn it. All right, never mind. So that's in there. Cat passes that text. That's the hash that's in there. That was 512, right? Yeah. So if you wanted a Hashcat, before I do that, I'll put more in there for example's sake. Let's do password 123, because that's an easy one. And then we'll do something more complex. Like this is like the standard recommendation. You swap out letters with characters and numbers, like password 123, right? So now passes.text has 3 hashes in there, and we're going to try to crunch them. Hashcat them, and we're going to see if we can do it. So I'm pretty sure Kali has Hashcat installed already. Hashcat double tag help, and it's going to be a lot of stuff, you know, if you have no idea what just happened. So I've noted this down. What we need to do: tech M is for method, A is for something. Damn it, already forgot. Oh yeah, that's for dictionary. Yeah, so we're looking for SHA-512. Here we go, 1171 or 1711. So what did I say? 1171. Yep. Like A is 0 for dictionary attack. We're gonna go back to output file, which is crack file dot text, and passes.text and the word list. So Kali has a lot of word lists of like commonly used passwords. We're going to use the RockU. Oh, I did not use RockU. Well, user share word list. I think it's RockU.text. If you haven't done it before, you'll have to extract it with gunzip. And I think that'll work, maybe, perhaps. What did I do? What did I do? It's quick, Kevin. Hit me with another one. Another word list that I can't think of. What if I just do this? No. Looks like it doesn't like the module. Yeah, I think it was 1. Hang on, don't worry. Don't worry. There's this thing called help, and it's a lot of stuff, but we're gonna find it. Don't worry. That too, but there's a lot of stuff. Here we go. So attack mode. Okay, that's what I did wrong, I think. No, that's what I did it right. What the heck am I doing wrong, man? Gosh. I don't need A? All right, well. That's probably what the mode is. That might be why. Module 01171. Don't worry, I'm figuring out. Unless I don't have 512 in this for some reason. Is it You swapped your ones. Is it 1711? Yeah. Is that right? Well, damn. I asked too. I was like, it's 1171, right? And no one said anything. All right. Thank you. I appreciate it. All right. Now it did something. It didn't work though. What the hell? It did something else though. That's what's cool. But no hash is loaded. Why not? I'm just MD5. Forget it. I did MD5 in my test, so I think I didn't do TR. That's probably what I didn't do, right? Whatever. So echo attack in password 123. Pipe that into MD5 sum. TR. Get rid of the hyphen. All right, I think it's this. Check my notes. Yep. And to passes.text. Yep, let's try baseball, because it's a cool password. Now we're gonna do an even cooler password, you know, baseball, you know, yeah. All right, now we're gonna try it again with 0 for MD5 hash. All right, it didn't cry. Yeah. I know it's a dictionary tag. It should be like instant or not. Ugh. I don't understand. It was working like yesterday. Did it? What was it? Crack that text. Yeah, I found one. Well, we did it. We got one. Didn't catch baseball. I'm surprised, actually. I could have sworn baseball we could caught 8 letters, all lowercase. But anyways, it caught password 123, which is a really simple password, which is in RockU. Okay, that's Hashcat. Let's go to, what's next? Crunch. Cool. Cool is pretty cool, because what it does, let's say you have a friend and he really, really likes golf, right? Let's say he likes Rory McIlroy. Well, what if he had his password, you know, something golf related, you know, Rory McIlroy related. So what you can do with cool is, we'll take him, min length, let's go with 8. All right, now let's go with 6. And yep, right to Rory McIlroy, or let's go with golf that text. Yep. And D for depth. So it's going to crawl a website. And what it can do is that it finds a link in the website, it can follow that link and also crawl that site too. I think default depth is 5. So we're going to go with 0, because that'll take a long ass time. So, and then the URL, let's go Rory McIlroy Wikipedia. We might find Professor Kyle Prather's password here. We may. And the link, absolutely not. So what it's doing right now is it's crawling, found a bunch of words that could be used as passwords. So we're going to cat golf, or let's type it in the less. It's probably a lot. Yeah, McIlroy championship, European, retrieved. You know, it's all these possible passwords.
It's Johnson.
Sergio Garcia. Yep. What is it? Cat golf. What is it? Word count? Yeah. So it found 2,200 possible candidates for a password off of one single page. So if we had like the crawl to like 5, that would have taken a long time, but would have found a lot more possible candidates. And a cool tool that you can use alongside this is called Crunch. Now, Crunch, well, it's called Crunch, but it doesn't really crunch anything. It's kind of different. But Crunch, let's go with min length, max length 3. It's going to create a bunch of 3-character combinations starting with A to Z, right? So you can use that to, because my password for Neopets back in 2008 was baseball 1999. So a terrible password with 4 numbers appended to it. It's pretty common. I wonder if your password has numbers appended to it for reasons. Yes, mine too. Don't worry, you're not alone. But you can use Crunch to produce your own word lists, different combinations. You can append those to your pre-existing word list. Hashcat has a tool called Merge, I think. It's under Hashcat utils. I don't think it's called Merge. Like, there's a thing, I forgot what it's called, but you can merge the names together combinatorially. That's pretty cool. Crunch can also do that, I think. Yeah, Crunch 00 TAC P. Let's go with Rory McIlroy. Yep. 2015. Just going to generate 6 lines. different combinations of the word input. So, I mean, if I were a developer for EA Sports who produced Rory McIlroy PGA Sports 2015, that could possibly be my password. I mean, I wouldn't try it, but it could be. I'm definitely going to tell Breakthrough tomorrow about this, but you funny. Go ahead.
Because Hashcat is optimized to use as much of your computer's resources as possible, you can actually specify, okay, I want it to be this length, but for these specific characters, either like at the end or something of length 8 plus some stuff, you can say, okay, well, it has to be a number and then a special character, or a number, special character. And so it'll actually sit there, it'll take your input, and it'll run all those combinations at the end and then go to the next.
Yes. And another thing you can do with Crunch is create your own format. Let's do 4 and 4. Tac T. If I can remember, I think it's character, number, I think. But yeah, never mind. That didn't work. Is it hashtag? Yeah, when Schoon did this last year, he had like 40 petabytes. I was like, wait a minute. Damn it, man, Crunch. Tac T, where are you at? Yeah, okay, so at lowercase commas, so percent, that's numbers. Okay, so percent. Let's type that into crunch.text. That's be pretty big. Yeah, somewhat large, so less crunch.text, and you get to go through all these combinations. So you can do that to append numbers to your passwords, make your own word lists for dictionary text. I saw a actual paper from like 2010 that was like, dictionary tags are dying, because in terms of computer hardware that's gotten better, processors have improved drastically more than storage. Back when we were on Intel Celeron with 0.7 gigahertz per core with a single core, you could only get a couple hashes a second. So you really wanted to avoid all that computational power running through all these hashes. So you used was it a rainbow table, or it was a rainbow table? That's what it was. Yeah, rainbow tables, I didn't go over these. Rainbow tables are pre-computed hashes, basically a giant list. Crackstation.net has one. I think it's like the world's largest rainbow table. And you can also buy, yeah, the really, really big ones. I think you can, here we go, download Crackstation's word list. 15 gigs uncompressed. It's kind of large, but there's some other ones like a terabyte for, a couple $100, but a rainbow table is, you can use it to compare password hashes with already pre-computed hashes. That way you can figure out what's done without, churning your own computational power. But what I was trying to say in the beginning is that processors have gotten so much better with graphics cards churning out literally terahashes a second. It's ridiculous compared to storage, which has gotten from, 10 gigs to 14 terabytes, maybe. I don't know. But they're saying that rainbow tables are dead because storage is too much, I guess. But like I said, looked at the Bitcoin hash rate. You're churning out millions of trillions of hashes and throwing them away. Imagine if those were harnessed and put into a file. That'd be a pretty big file, a gigantic rainbow table, which I think is going to be my idea for senior design, creating a blockchain rainbow table. That'd be so cool, but don't steal it yet. It's still my idea. Unless I don't do it, then you can just put my name on it. It'd be a cool project, but maybe that's kind of it for passwords. We could talk for another hour for passwords because there's so much to talk about. But yeah, that's kind of it. If you want to stay for tutoring, come on down.
That's kind of what blockchains are, though.
Yeah, they're gigantic files.
Because you're taking taking a certain input,
enormous linked list.
you're taking a certain amount of inputs, and because you're verifying cryptographic, right? It's ECC, right?
Yes.
You're verifying them with a nonce, and so you're basically just trying to find the nonce that makes that hash.
Yeah, and you're throwing away all those hashes. Trillions of trillions.
Verifying the transaction. The output verifies the transaction.
Yeah. But what if you could harness it slightly?
So the reason why you need to use work in the first place is because gaining a 51% advantage over everyone.
Yeah, because you can make your own. Yeah, it is. It happened like once with Ethereum Classic. Huh?
The Bitcoin hashes you were talking about?
Yeah.
Or is that just like the hashes for each like transaction, like a blockchain?
Currently on the current blockchain being executed every second is 160 million trillion hashes to verify transactions. Yeah.
Yeah, I understand it's like just a lot of people saying that, that's that transaction.
Yeah.
The way that it works, the algorithm behind it automatically adjusts the mathematical
All right.
based on how quickly it solves balance. It looks at the
42 characters might be a lot to remember, but it's not bad. I mean, if you're just copying and pasting it, can't hurt. Some websites might have a limit, like some limit 20 characters for a reason, but it's probably not bad. I'm gonna go ahead and end this.
Because statistics tells you if everyone is in total, sum total, producing this many hashes per second,
Okay.
then